I'll flick through some of these slides because Perry's actually mentioned it, so we won't delay it. And I'm not talking about connectors. I'm talking about the cost of these buildings. And though I'm first going to talk about the elephant in the room. I'm from the timber industry, therefore I'm biased as all blazers. But when we develop these costings, we use Rawlinson as the basis to it, and market prices were available. So please forgive me for that, but that's the way to do it. We also use an odd footprint of the building parameters, and that's mainly due to the fact that we wanted to be fair to all systems. So the grids wasn't favouring one system. So the 20x30 was a system which allowed us to have a concrete solution and a timber solution with the various grid spacings that we've used in the various 3 models to work out without favouring one system over another. So we see this being a little bit of modular and would work forward with that for wider and taller buildings. So the concrete assumptions, look, and again I'll just rush through these. Yeah, they're just a standard post-stress band beam system. And we saw a timber version earlier on. Now this is the concrete one. So we just did that against a 9x9 meter grid, and we used the rates from Rawlinson, and the design was reviewed by T2W. So that was the basic concrete one. And what we're doing here is just reviewing the superstructure costs. We aren't reviewing any other costs. We just assume all of those are equivalent between the buildings, and that and we're just getting a value for the superstructure. So we look at the outcome for the concrete one. We find that it worked out to about $549 per square meter, and beams, floor, columns, no connectors, false work, and the labour in this, how Rawlinson does it, is included into the rates of the beam and column, so the concrete rates. So there's no labour there. And we go on to the edge support system, which Perry described, which is a complete rip-off from the Brock Commons project. In this one, we used the CLT floor system on Glulam columns, and we used the rates, which is, again, this costing was done more than 12 months ago. So prices here are probably unapplicable today, but they are. It's all scalable. The concrete cost has always also changed. So we used the rates that we were able to get from the marketplace and applied them to the various systems. In this one, we used, as Perry said, we used the pillar rotherblast connections through the floor system, and that was a fairly efficient way of designing. So just a bit of a floor plan of that. You can see there's a bit of detail there, but we had a lot of columns being used with and supporting the edge of the CLT floor systems, and then joining the CLT floor systems by mechanical connections. This one we used a temporary prop system, which was similar to Brock Commons again, which is just the space between the columns. In that, we assumed there was 2 sets of formwork being used, so that they were leapfrogging up the building. Additional handrails were added to it, and that was, as we've seen before, is because we're having to meet the safety requirements of getting on top of the platform and putting the screws in. Crew of 9, and the rate we just used is $90 per hour for Rawlinson for Sydney. And interestingly, and we debated this at our workshops, is that we just didn't use the time that was the program time. And I can tell you, Perry and myself debated that program time to the cows come home, but we put in an inefficiency rate of 40%. We originally had a 50% inefficiency rate, but our tier 1, tier 2 contractors said we were too harsh on ourselves, so we reduced it to 40%. But there's inefficiency, and that means when the crane's idle or something's happened or the wind come up, whatever it is, it accounts for those things, and people going off and off the building and into the day. So that's been used on our timber costing system right throughout. In this one, we can see from that we have no beams. That's the beauty about this post and plate system. So it's the floor, columns, connectors, the false work, and the labour, and that ended up being a bit cheaper than the concrete at $514 per square metre. The one that Perry talked about in more detail was the centre support system. So it used pretty similar rates to what we just saw with the edge support system, but it used as Perry described, the spider connection. So we got prices for spider connection directly from Rotherblast and use those as recommended retail rates, as well as the rates for everywhere else. And note that we did actually decide there, this has been designed for fire, so we had fire protection being achieved through additional cover and timber, and that actually dominated the size of some of our columns. In this case, it's as Perry described, we were putting down a layer of CLT panels down through the column line, and then infilling them with it. And there's no doubt by doing that process, it reduced the amount of material being made, but the offset of that was the far higher number of connectors being used, and we had a lot more connectors being there, which equated to more time. And Perry detailed what those things. And we use the XFit, and we're still a little bit unsure of the infill panels, because we need to account for construction tolerances, and some of these assumptions are based on intimate contact with each other, and so we think there's a little bit more work needed to be done there just to make sure that's possible. So as Perry just said, so I won't dwell on it. We used a offsite manufacturing and delivering to on-site, and again we use the $90 hour rate with a 40% inefficiency. Its rate was a bit more expensive at $5.36 per square metre, but again, no beams. And in this case, it was a little bit more material, but the columns were less. Our final system was the band beam system. So we saw an example of the Maryborough fire station. So this one we actually had designed, and a lot of the system that was used in the Maryborough fire station is what we used in this cost plan. So it's again going through a very similar process. It has a bit more material than the other two systems because it has that beam, the band beam, being used, and that adds to the material cost. So you can just imagine the first thing is the construction process as you lay down your beam, your band beam, on top of your columns, and then you support it. Then you overlay your floor which goes perpendicular to the direction of the band beam, and that is connected together to increase the depth of the beam, as well as acting as the floor between the beam. And it amazes me, but what we're doing here, and it comes back to this fundamental likeness between timber and concrete, is the compressive strength of timber is pretty much the same as concrete, and all the tricks that we can use with concrete, it can be overlapped onto timber. And finally, we have to connect all the panels together to give you your transfer of forces, and so there's another layer of connectors and screws put into this building. So there's no doubt these post and plate systems have a lot more fixings being put into and fasteners being put into it, which needed to be costed for it. So again, we had connector costs. The force work was in case of temporary form work, like we use in concrete thing, but wasn't over the entire floor. It was just part of it, and using the same hourly rate of $90 and the inefficiency of 40%. In this case, this is probably the most expensive of all the systems. It's $618 per square metre. But if I look at these overall and compare them side by side, ends up that the cheapest of all three was the edge support, followed by the centre support, concrete, then band beam. And what the problem with why the costly more for the band beam is that it had more material in it. But interesting, and Perry and myself spent a great deal of time looking at the labour costs, and we were looking at programs, how many people and how long it was going to take. But if you look at the amount of labour costs in this thing, it is actually not sensitive to the overall cost. We could have doubled the labour costs and still had a little effect on the comparison between the systems. So it's interesting to see that these post and plate systems are not labour sensitive, and even though we did their utmost and put inefficiency rates in that, it wasn't a criteria. It really is a material cost. The labour was about 5% of the overall superstructure cost. I facetiously said to people that you may be able to negotiate that 5% labour cost out of material supply, but I'll leave that to others. So you look at in ratios to them, focusing on the savings, no preliminary costs involved. The centre support system, the closest span is the cheapest, followed by edge support, then the concrete, then band beam. But if you want a little bit really clearer, preliminary costs, which is the cost of equipment for hire and things like that, non-productive costs, the construction company staff and things like that. Well, then you include those things, and the actual fact you'll find that the preliminary costs actually do change around the order of things, and by far the centre support system is cheaper, and the band beam becomes cheaper than the concrete solution. So and all of that, we kind of think that these type of systems is really the future. they need a lot more work in establishing the bona fides, but we do think there's something to do with it. But as Perry alluded to, we do have one issue, and that's what's left to do, and that's to find a competitive method mechanically joining, CLT. Here's a bit of welded wood, just to, where we can, ideally where we wanted to get to would be like a welded wood connection, but we weren't able to do that. So we need a connector system which is, a lot of the elements installed in the factory, minimize milling, use commonly available low expensive materials, best if panel required, no force work, joints may be able to be fire rated and embedded within CLT, allow adjustment on site for some tolerance issues, because there's always shrinkage expansion timber, and finally be quick to install with a minimum workforce. So there's our a mantra for what we want to get to our connector system, and we'll be quite honest, we felt that there's one that was to be done, and that's future work. So if anybody's got any suggestions there for connector systems, let us know. So the last slide is just a couple of things. Is the connector system also needs to be is really a tension tie, but we also found that the tolerances meant that we weren't getting intimate contact between the compression faces of the connections. So we need some more thoughts with that. And overall, the robustness consideration must be used. We did use this system on the calculation and design, which is basically a steel sleeve system, a circular hollow section joiner, which we just copied off Swedish wood concept, which has been around for about 10 years. So we looked at about about two dozen different systems. We ended up with this one, which was been hanging around for a long time. So that's it, Colin.
Cool. Thank you so much, Andrew. We'll just ask a question or two before we wrap up. So I've got a question here saying, asking about how lateral loads have been considered for this system. Perry or Andrew, would you like to tackle that?
All right, I'll play the structural engineer. That's a good point, and thanks for that question. We assume that those lateral loads will be taken out by other means, such as a core or bracing. They're not been included into this because it was just really about the superstructure of it all. So is
that a fair comparison to concrete? Yes, because concrete will be in the core.
Yeah, obviously there's a core there which is not included in the costing there. So yes, good comment.
Cool. Other question is, what inspired the research into person plate systems? Was it the Rock Commons project, or was it something else specific in Australia that inspired this research, Perry?
I guess it was largely that we were trying to reduce the kit of parts and simplicity, and as I said, we were looking at trying to reduce the number beam depth and things like that to make it more competitive with flat plate concrete construction that a lot of developers would use. It's fairly common around here. And so and I guess we were looking at, just trying to reduce the amount of labour on site, simple system that didn't require too much machining off site. And so they were the main drivers. I guess in a nutshell, flat plate construction is very common, and we needed to come up with a system that competed with that. And so that meant getting rid of particularly beams, and it had other connotations. But that was probably the main driver.
Yeah, love it. I think getting away from the penetrated beam is always going to be a good thing for timber.
Yeah, I'm just going to add there, and Colin, is that also it's the flexibility of the floor plate. We were finding that the systems before, with particularly stacked systems, were locking in the load-bearing walls, and that doesn't suit the developers who are building some of these buildings. They want flexibility of floor plate.
I guess there is one thing worth adding, and that is that the concrete flat plate systems are generally on around an 8.4 up to 9 metre column grid, which is there for a number of reasons. One of them is around car park spacings in the basement. If you've got a continuous load pathway down through the building without transfer slabs, and I guess that's something we're aiming for, but we.
That's a tricky specification to reach.
6.8 metres. So that might be more achievable for suburban offices and things like that than prime CBD, where they're particularly interested in the column layout so that it doesn't affect their net lettable yield.
Yeah, obviously school buildings and fire stations there, Perry.
Yeah, sorry. Add those.
Well, that leads on to my last question for you, Katie. following this project, are there any more on the works for us?
Fire stations? Not that I'm
Or-
aware of.
Or schools or any other ones that are using this sort of system that demands sort of open layout that the system's been optimized for?
Absolutely, there's plenty of projects underway, and the XLAM plant is scaling up with extra shifts and so on.
Cool. That's awesome. All right. Thank you, guys. I'm just going to do a quick wrap up before we go. So just so everyone's aware, the Timber Design Awards for 2023 are going to be opening soon. So if you know anyone who has built a timber building in the last year that could be a winner, then do let them know. Other thing is to please get in touch with Andrew if you are at all interested in learning about or contributing to the Australian Mass Timber Full Scale Test Program. And finally, our continuation of the WoodSolutions webinar series will occur next month on the 7th of March. It'll be on timber flooring by Phil Buckley, who's an expert on timber flooring specifications. So a great one for architects and homeowners. We also have a WoodSolutions seminar in Victoria in late Feb. So if you're in Melbourne in late Feb, there's going to be a fantastic presentation hosted by Alistair on the 2022 Australian Timber Design Awards winners, hosted in the library at the Dock Performance Centre, which is one of Australia's incipient timber buildings. So that's sure to be a fantastic event. So make sure if you're in Melbourne, you get along to that. So thank you very much to our hosts, Katie, Perry and Andrew. Very much appreciate your time today. And we hope that you have a great day. Thank you so much.